Oh boy, here's Kaczynski coming back at you with a little more 11.5. Today we're talking about regular polygons. We're going to get to a formula, but first we need some vocabulary. In case you think this vocabulary seems random, it is in case this polygon is inscribed in a circle, which means the circle is circumscribed, then all of the vertices of the polygon lie on that circle, and that's why we call it point N the center of the circle and the polygon. Segment NY is a radius of the circle and the polygon, and our segment NS is an apothem, which is both perpendicular and bisecting. And that's fantastic. We should add one extra thing too. What the heck? Make sure we have all the vocab. I'm going to go ahead and go up here where it's going to be out of our way for later. But we could say that angle PNO is a central angle, which goes back to our chapter 10 stuff. All right, speaking about a blast from the past, guess what we're doing? We're going to chapter 7. We had a formula 180 n minus 2 over n, and that is for any interior angle of a regular polygon. In the case of our hexagon, we're going to put 6 into that formula, and that's going to give us 120 degrees for every angle. But when we draw segment NY, it's taking that angle and cutting it in half, bisecting it. So there's our 60. So we have a 30, 60, 90 for hexagons, which is great. So anyway, I'll pause for a second. In the hexagons, this is the only shape. If we draw all of the radii, we have an equilateral triangle. In any other regular polygon, they will just be isosceles triangles. So that might even be a little trick for you with the regular polygon, with the hexagon, that you can just use the all equilateral triangles versus anything else. But any other shape will be isosceles. So what is the formula? I know you're in suspense over here. So the idea would be, though, if I wanted to add all of those triangles together, so if we were to add all of the bases of those triangles, that would be the perimeter of the polygon, and then the height of every triangle that you could draw is the apothem. So 1/2 PA, make sure to add that to your formula sheet in regular polygons, and that's fantastic. We'll practice using it on the next video.